This is Dr. Rajni Sharma, and today I am going to deal with Pascal's law. It deals with the fluid at rest, and the branches of science which deal with the fluid at rest is known as hydrostats. Actually, the fluid can be any substance which starts flowing when external force applied to it. And I already have told that the fluid at rest is studied under the branch of science known as hydrostatics. Before dealing about the Pascal's law, I will tell you some facts about the liquid. When liquid is at rest and it is in equilibrium, then it will exert force normal to the surface which is in contact with it. It can be either the upper surface, can be the wall, the lower surface, and anywhere in the container. Suppose the container filled with water, and suppose I am wrong, that is, the force is not normal to the surface. So the force will be applied to an angle, and the opposite force will be along the OA. So suppose that this force is inclined to the angle theta with the surface or the bottom of the container. Then we can resolve this into two rectangular components as f sine theta and f cos theta. But the liquid, as it is in rest, it is not flowing. And if we will consider this f cos theta, then the liquid should start flowing at this direction, but it is not so. So we can say that f cos theta is equals to 0. But the force can never be 0. So here we will consider that cos theta is 0. So the cos theta is 0, it means the theta is inclined at angle 90 degrees, which means normal to the surface. So this proves that the force at anywhere in the container will be normal to the surface. Now consider another condition, which is the Pascal's law. Consider the 2 points A and B. Now draw a cylinder with an axis A and B imaginary. Then the force will apply to the cylinder will be normal from the all side. And here we will consider that A is the cross-sectional area of the cylinder. P1 and P2 is the pressure exerted at A and B respectively, and F1 and F2 is the force exerted at A and B respectively. Now I am shifting this diagram to the right one so that I can show you. We know that force is equals to pressure into area. So here F1, which is the force exerted at A, will be P1 into A. Similarly, F2, which is the force exerted at point P, will be P2 into A. So we know that the force exerted at this point will be equal. So it will be F1 is equals to F2. So we can say that P1A is equals to P2A, which means pressure at A and pressure B will be equal. And this is what known as Pascal's law. It means that the Pascal laws state that pressure at anywhere in the liquid will be equal. Now, this law also accounts for the principle of transmission of pressure in liquid or gases. In this form, Pascal's law states that increase in pressure at any one point of the enclosed liquid in equilibrium of rest is transmitted equally to all other points of the liquid and also to the walls of the container, provided the effect of gravity is neglected. So let's see this, how this happens. This is a container having 4 pistons, piston A, B, C and D. Now, let A is the area of this piston, A by 2, this area, A to A, and trace the area of this piston. Now, when force is applied on the piston A, then force will be applied from the inner side to all the piston. To maintain its position, the piston will apply its own force toward the opposite side. F by 2 by this piston, which having area A by 2, 2F by 3rd and 3F by 4th piston. We know that force is pressure is equals to force per unit area. So when we will calculate the pressure exerted by each piston opposite to the force applied by the liquid to it will be equals to F by A by this piston. Similarly, by the all pistons, it will be F by A, which proves the Pascal's law, which states that the pressure at any point and the container exerted by liquid will be equal. So this was the Pascal's law. Hope you have understood it very clearly and enjoyed this video. For more video and any more topic, if you want any more topic, don't forget to comment on my channel so that I can prepare for that for you. And don't forget to subscribe my channel for such interesting videos. Till then, goodbye and have a nice day.